Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and this is, I believe, the start of Do-Over Part 6. And we're going to start off with a little milling work here, and we're gonna do some milling work in the Bridgeport to get this ball rolling, because we have a hole pattern here with a through hole and a countersink for probably a flathead fillister style screw. Was common in a lot of older machinery. And then we have two flats on this part, and the flats are in line with the square. Now we're going to bring over our old part because we want to confirm that this hole pattern originally was drilled as a uniform 6-hole pattern. And we got our index head up here, and it's loose, it's sliding. We've already confirmed it has the masking plate in it so that we can quickly index 6 points. And this is going to be set up. We're going to go through setting up our dividing head on here so that we know it's square, and it will repeat for the drilling operation and the milling operation. And of course, in a 3-jaw, you're always going to have one jaw in the way of doing a two-sided part. So we're going to have to index this in the hole down itself to pick up the secondary flat. And so anyway, let's bring you in close and let's get going on this project. All right, let's get ready. We're gonna bolt this down with the center T slot here, so we're gonna go ahead and quickly screw in our T nuts here. We're gonna drop on, if we can hang on to them, we're gonna drop on a couple of our nuts and washers, both sides here. Okay, they're still loose, so we can still move everything around. All right, now we're going to crank this in. Make sure there's no grit on either one of those. We're going to push this all the way forward like that so that we can watch it right here and know when we actually make contact with those ways back there. Now that's machine surface against machine surface. And right there we can see, we just make sure that we have a stop there for our mill scales for the readout, so we don't have to worry about injuring those. The groove right now is about split even. Okay, we're going to go ahead and tighten our two hold downs. Okay. Okay, that squares the index head with the table and the axis. That's going to be important because we want to index our square. We're going to have this set up in the middle right here. We already got this, it's just loose. But we're going to have it set up, and here's a free area here to do a square. And then we're going to have to index this in the machine to bring this around and be able to mill this square over here. And that's why we want this index head to be square. Otherwise we can just zero in on it wherever it's bolted down, or no matter what rotation this is here. After you dial it in 0 and you index it, you will automatically have 6 equal holes. But the 6 equal holes also are square against the two, lined up with the center line of these two right here. All right, so anyhow, there's our sample part we're going to be following, and we're going to be taking some measurements across the chords here, and we're going to bring over the other part, and we're going to do some measurements across the chords there as well. But let's go ahead and set up our ring in here now. And of course, if I just go like this, put this down here and tighten it up, we could possibly put some jaw marks on here. So I'm going to insert the aluminum ring in here again. Okay, now that that's in there, now we can come in here with an indicator and we're going to sweep this, and that's going to give us 0 with the center of the index head. Alright, we just pulled our chuck out so that I can grab the snout of this, because I'm going to use an indicator clamp that, this is an old favorite. I don't know how many years I've had this, but this is made just so that it clamps right up to your spindle, and then when you put it in neutral here, you're able to spin this around. If you drop it down a little bit there, it won't rub, and it's really convenient. Alright. So this lets you actually have the spindle swing, and then you can take and start with all these things being loose. There we go. Okay, after you have it, capabilities of swinging it, and almost bottoms out there, but I kind of look at this and it's not quite center, so I want to swing this indicator just around a little bit here. There we go. Okay, so now you can just take and go forward and aft. There's 0, and bring it on back. We're almost 100 this way here. We're going to bring it down just a little bit more here. About 45, and we got 70. It's 55, 55, about 54, 57. Alright, we're within 1/1000ths right now of being center. So now what I'm going to do is I'm going to lock my knee and my cross slide and the x-axis on the table, so that I've taken the gibs and tightened everything up, and now I'm going to have a different reading here, because this thing is loose as a goose here, and there we go. There's 0. See, we got +7, we got +2. Alright, I brought you in close here so that show you what we settled on, and right in there I believe that's at 0, and let's see if I can get this is my bestest mirror here. Okay, so we're like a -0.5, and like a -0.5 there as well. Let's see if we can get that. There you go. Okay, and can we get that over there as well? Let's see. Alright, and back to 0. Alright, I'm gonna live with that. Yeah, I have to laugh. I've had this for a long time. I had to drag this out because somewhere I lost my my square one I had. Somewhere it's around here. I haven't been able to find it, so I dug this out of my old box there. And I was in the bilges one day and I lost the round lens out of here. It went down in the bilges, and I had a square one, and I had a little glass cutter. So anyway, I hand shaped out a circle as best as I could, and then I took and I tapped it lightly, and you can see there's still jagged all the way around the edges, and then I took a piece of double back tape and I stuck it in there, and it's been there for quite a few years. Okay, let's go ahead and bring up our quill here, pull our indicator, and we're going to zero out our readout so that we now know that we're exactly 0, and we want to tag in the readout before we crank in any handles or move from this spot. And now I'm going to go ahead and bring over the receiver for our part, and we're going to be measuring across the chords on that part. We're going to be measuring across the chords on this part here, and we're going to decipher this pattern so that we can create it into this part here before we cut the flats. Okay, we went and got some 5/16 bolts here so that we can measure the whole pattern. And we're worried, or we're not worried, we're looking to find a common a common pattern here, and what this bolt pattern is originally. And because we do have a discrepancy on that bolt, it's two bolts blending into each other. So we got 5 inches for 90, and we come over this way, you got like 93, 94, and also if we put these bolts right across here, and of course we only screw this one in a little bit. It has a good start at the top of the hole, but as you put it in, it wanders into the other hole, so it angles. But with it in its original spot, and this one held in its spot there, we're getting 5 inches 492. So we got the common dimension all the way around, so we know that it was a uniform hole pattern. Now we took our bolt diameter here, which is 304, 305, and we subtracted that from our 5 inches 494, somewhere around there. We come up with 5 3/16. So the whole pattern is 5 3/16. The other thing that we actually did check was measuring our chord pattern between each one of them, and they all jived except for this one here. And this, you could hold this up in here and you can get it to match. Okay, we're gonna get our drill chuck back in here, and we're basically gonna start out at 0. We'll lock it down our head here. We'll verify we are on 0 on our rotation there, and we're going to come straight across here and locate this at the radius at 2 inches 593 and a half. Will give us the location out to this hole here, and then we're going to index at 6 points from there. That'll give all of us our holes. Then we'll come back to our 0, we'll lock it down, then we'll change out our drill chuck to an end mill, and then we'll cut this down to size, and then we'll put our locating drill bit or chuck back in here. We'll come back and we'll locate this hole, and then we're going to spin this part around and verify that we spun this in the jaw, locating that hole, and then we'll be able to do this cut here. And that'll be the first step of all the mill work, and then we'll worry about the slicing and the cut, and also the scalloping for the squeezing bolt assembly. I know you're thinking, well, what are you going to do about this hole problem? Well, I have an idea, and I'm kind of going through it in my head here, and I will bring you into par when I got the plan for this hole finalized. But we're going to do a repair on this hole for the customer. Now, we don't want to heat it up. We don't want to do any welding on this area right here, because we don't want to destroy any of the dimensions. So I'm going to come up with a non-welding repair that will get us back to a single hole here. Okay, we put our drill chuck in, and here's a piece of 5/16, and that's kind of like an eyeball guide here. Alright, so we want to come on over 2 inches 593 and a half. 81, 90, 90, 93 or 94 is good. Okay, and then we take our part. We take our part here and bring down this, kind of like just stick it loosely in a hole right there. Okay, and then we kind of move this back and forth. We're feeling the outside, we're feeling the inside there. The inside feels like it's really lining up. Okay, so just by eyeball, I'm verifying I'm going to be happy with that pattern. Alright, so now we're going to go around and we're going to create the pattern. 5/16, let's see what they got in here. For a hole size, it's like 321. 325. .320. All right, so we're going to go look for a drill bit that's real close to our 320 mark, and we'll come back and we'll put that in there, and we're going to do our 6-hole pattern in here. All right, lock our table, ready to go. This drill bit, I put it in and it turns pretty true, but I just figured let's go around and let's spot the start. So I put in a starter drill. This is a carbide drill bit, and not that we're going to spin hard or anything else. It's just what I have on hand. All right. Get my handle situated. Get my clearance with my readout support here. Okay, here we go. Now I'm just spotting them. I'm not going to try to drill all the way through, and I'm just ratcheting with that masking plate underneath there. It automatically will register the next point. So I don't have to look over the side or concentrate on where it's going. It automatically puts those locations right in there. Okay. By the way, this is a phase 2 super spacer, and my rotary table is also a phase 2, and I have nothing bad to say about these products. I really like them. I think they're very much well worth the dollar you spend. I have no complaints. And they are made in China. There's good China and there's bad China. All right. Oh, what we ended up coming in, we ended up this is a P drill. A P drill is I believe 322, 323, somewhere around there, thousands. Really try to be careful coming all the way through the bottom there. I used to, you know, ductile material is a little bit tougher than cast iron, but you don't want to be chipping or breaking or cracking on the way out. You want it to be a smooth cut. Okay, we'll go ahead and start setting up for the counter bore, and I believe that is 1/2 inch in here. Let's see what we got. No, actually clearance for 7/16. This is like 450. All right, we're gonna go see what we have for a an end mill that would be in that ballpark area where we'll be coming down and create that counter bore. Okay, believe it or not, in one of the toolboxes I have in there, I just went rummaging around. Now we needed 450, and this happens to be about 446, 47, somewhere around in there. It's a regrind. This is an oldie, Regal, HCSC. I don't know if that's high-speed cobalt or it's another Signia there, 1/2 inch. So we're going to pull out our drill chuck and switch out 1/2 inch collet, and we're going to get in there. I did test fit this here. It almost stands up by itself. It feels real good in there. I think it's going to be good. These were made to have a little clearance, and it definitely feels like it. That one's got, of course, that one's got hammer noogies, and it is slightly dulled on the edge. I can see where it's been a little bit warmed up, but I think it's still still feels like it could pull a chip. And this is ductile. It's not real hard stuff, so we should be able to get by with this. And that's what we're going to do. All right, let's pull out that collet. All right, we're bringing her up to just about where our end mill is there now. Okay, I like that. Okay, now we're gonna bring it on down. Touch it down here. We're gonna set 0 here. All right. Now I want to measure the depth we got on the other part here. Okay, about looks like 1 inch. 1 inch 65 right there. Okay, but put your depth mic always down on a flat spot and look at what it reads. Okay, I'm reading about 4 plus. Okay, so about 160. 160 is our depth. I'm just saying that this is made for taking depths, but these indicators don't always give you a true depth off the end there. And this just happens to be about 4 or 5 thousandths on the plus side of your reading. So I get 165. I'm going to call it 160. And 160 is what I'm going to create for the depth on this. So we set that at 0. And I think that's going to be slow enough. All right, we're going to bring it down here, and then we're going to engage. I'm engaging my wheel so that I can control my wheel here. All right, we're going to come on down. We're about 50 thousandths, 20 thousandths, 10 thousandths, 5. We should be getting close to touching 0. All right, so we are pretty close there. All right, we're just making sure that everything is locked. You don't want no vibration when this comes down in there. So we're going to take it at 160. There's 50. There's 100. 150, 160. All right, let's get the vacuum here. Let's take a look at our hole. Let's see if we can zoom you in and take a look at that hole here. Does that help you any? All right. Probably don't get the right straight on down in shot here, but let's go ahead. Let's we're just gonna quickly. We're gonna go to the next one. Down close. 30, 20, 10, 0 should be touching. There's 50. That's 100. 150, 60. Okay, we're just gonna leave it like that. We're gonna come on around. We're just gonna go right on through them, slam them out. All right, we're 40 plus there. 20, 10, touching. There's 50. There's 100. 150, 160. Close to touching. There's 100, 50, 25, 5, touching. 50,000, 100,000, 150, 160. Sometimes when you're holding things real gingerly, you don't want to slam this thing. I had one index head that you could ratchet it, and it would move so fast it would actually slip the part in your jaws if you weren't holding it tight enough. I'm just saying. 10, 0 touch. 50. 100. 150, 160. And our last hole. Come on down close. Touching. 50. 100. 150, 160. All right, let's get the vacuum here. Okay, so our location that we're at is 2 inches 593 from center and 0 in line. Now we need to go ahead and set this up and cut that mill flat. So let's bring us back to our 0, which is right there. And now we'll be able to come over here and mill that flat between those two holes on that side right there. And we could use this end mill. There's no reason why we can't use that end mill. Okay, so we're going to come back to 0 this way. Alright, then we come back out here, and then when we come in and touch and visually see our touch there, we'll be actually locating this outside diameter. Now we're going to go ahead and we're going to measure across. Let's see, is there any material there they left us to measure across? We'll measure this, subtract this, and that'll give us our depth that we're going to be bringing in here. And we'll also go ahead and we'll measure this here as well. We could actually measure, there's several different ways you can go ahead and figure out what that's going to be. We could actually measure across the bore in here and measure that right now and subtract that as well. So you can go off the diameter, you can go off the radius, you can go off the bore to the outside. There's a lot of different ways to do it. But first thing, we're going to go ahead and we're going to come in and we're going to touch it. And I'm going to steer off this way here because I can see the light back here. And there's the touch. And that's at 3 inches 157. 3 inches 157. So we write that dimension down there, right there. Okay, 303 is what we're going to be coming off of there with. Alright, so I'm going to go ahead and bring it back here, and I'm going to feed in, and let's see if we can get you in here and watch a little closer. Okay, so we're going to be coming into a minus 2854. I just want to make sure that I wasn't going to go too far, but here we go. That should be 100 thousandths right there. We're hugging high on that end mill there. That's cutting pretty good. We're clipping along pretty good. Vibration seems to be minimum. Whoop. Well, there you go.